this term. So if you observe one thing, let me take one more step. I will do derivation. I is equal to 1 to capital d by dt and r dot, and then it will be equal to with rho r by rho qk is equal to, will get sigma is equal to I1 to capital M, and this term is there, and r double dot qk plus this term I can change is like r dot is there. R dot means I can take away velocity. Here keep in mind this is velocity and that is not velocity, that is potential energy. So d vector, and then this one if I keep d by dt with respect to means that r if I take, then it will be also v vector dot, and it will be rho q. Similarly, if I think in this one, see here, if you know this one I can make change where we convert into velocity, so this will be velocity. Similarly, if you think this term, this one, let me work on this one. Okay. Dou r by dou qk. So can I write in this dou r by dou t divided by dou qk by dou t, and this one I can write r dot divided by dou qk dot, sorry. So both are same. Let me take it like that. So I can write like this, and here also like this. So now I think you are clear here till now, and if you observe that this is the term same we got now, I write, if you have written everything, you can, this term is same it which was inside that I is equal to 1 to k is equal to 1 to small n, and then inside we got sigma I is equal to 1 to capital M, and we had m double r dot and dou r by dou qk equal to, okay, this was the equation. So this is the term like this. So I can do, what can I do? I will keep it in one side, and other part, all these things I will send to next side. So if I keep it bracket, open the bracket, the sigma sign will also come with here also. So how can I write? I will write it like this term will come I is equal to 1 to capital N and m r double dot dou r by dou qk. qk is equal to, you will get sigma of I is equal to 1 to 1 and d by dt mv, and this one also I can convert into velocity, so it will be dou v by dou qk dot, and minus, I will keep bracket here, so sigma, that sigma means addition of that, this symbol come here out common, and it will be mv vector dot, okay, here it will be, here dot will what we want be there, it will be d by dt r by, so it will be r dot we can write v, so it will be like this, no qk v, this one. Now if I change in this one, we may change in this equation capital N. So if I see this, I can write d by dt, and it can be written as d by dou half mv square. Similarly, this can be written as this can be written in form of half mv square. How it can be written? That if I take half mv square in my hand, and if I means f is a function of half m, if I differentiate with respect to velocity, then it will be half m, and velocity respect to 2v, and dv by dv means it will be 2v. Now d function if I take, then it will be 2 cancel out with 2, so it will be mv dv. This dv will come. Same equality there in dou. So this is partial derivative. So this time can be converted into this form. So this is the same thing. So here what is the f function? F function is this one. Then half mv square. So this is like that. Again I will write. This is the function like that. qk half mv square. So here what will I do? This is differentiable by velocity, which means that function is, if I differentiate with this, so I can differentiate with velocity, and velocity I can differentiate with qk. So like this I can do. Means like first I will mv square by d half dt, and dou t by dou qk I can do. So here I will do, then it will be mv, and sorry, here v. So mv it will be, and dou v by dou qk. You got same expression. I think this is clear now. Thing is that I am differentiating in the, if you see here, this is not differentiable with qk, but I can differentiate with velocity, and velocity I can differentiate with qk. So this half mv square I am differentiating with velocity v with respect to v, and v I am differentiating with qk. So both are the same. Similarly in that thing also. So now if I keep this value, so it will be equal to y is equal to 1 to n, and is there anything left out? So this is the equation number 3, 4, 5, whatever. Let me try 4. This is the equation number 4, and let me keep it in question. What was our name? This one. So if I keep it here, then it will be k is equal to 1 to small n. Now I can take this, and means integration if I take inside. This is not integration symbol I made. I forgot that time what to say. So if I take it inside, then I can write like this. Dot qk, and it will come inside half mv square. Similarly, minus, and del by dou qk small n, and half mv square. This is the total kinetic energy. So I can show like this: d by dt, and it will come total kinetic energy. So T minus this is T. So, and what are the right hand side? Right hand side are sigma of I2 1 to capital N M R double dou R by dou qk. This is the equation number 5. Here T is the total kinetic energy. So now let me keep the value of this fifth in equation number, not in this one, here in this one, right hand side part. So we will get like, it will be, otherwise I can make change here only. So this is the equation, this capital bracket, and here we will get 2k, and here I will get k is equal to 1 to small n. This is the right hand side part, R X S LHS is equal to RHS. LHS equal to, we got sigma of minus. Here I did not mention minus. Sigma of k is equal to 1 to small n and qk is equal to right hand side, which is n is equal to k is equal to 1 to n on this one. So d by dt dou t by dou qk dot minus del t by del qk. So now both are equal. If I take this equation in this side, so it will be like equal to k is equal to 1 to n, and it will become d by dt. It will be d by dt and dou t, so qk minus dou t by qk plus this will be k is equal to 1 to small n dou b by dou qk is equal to 0. This equation finally we got. Now we solve both the equation and we have seen. So if I move further, only 2 or 3 steps are remaining. Almost we have close to our result. So let me remove it as another. Now finally we got this equation, and in this one, if I take in bracket here, wait. Here was del qk, here was del qk. You see, in previous equation, left hand side, right hand side, you will see. Then here you had del qk plus here it will qk del qk is equal to 0 degrees. So del qk, let me take it common, and it will be equal to here k is equal to 1 to smaller. So I can write k is equal to 1 to, it will be common, and it will be d by dt dou t by dou qk minus dou t by dou qk plus dou v by dou qk del qk. Now let me write it combinedly, and I can is equal to 0. So it will be k is equal to 1 to n d by dt, and it will become dou t by dou qk minus del by dou qk, same t minus v I can write. So this is the equation, and here sorry again I made mistake. Here was in previous, this is there. So I forgot to write dot. So that in you check also, is there any other mistakes, correct it, because calculation I am very poor. Many times I make mistake. So in this one, so if you see here we got T minus V, here T means kinetic energy, potential energy, here only kinetic energy. So I want to make change in this way, but here the icon means it's not there. I can do, but I know that this is the independent of Q dot QK only, or QK means here if I take QK dot, it will not change, or if it is independent of QK, then if I differentiate with QK, it will give 0 value. So what can I do? I can write like this. You did, I think you did not get. Means Here qk dot is there and V potential energy is not dependent on qk dot. Qk dot, it is independent on this. So if I differentiate with qk dot, this value is, if any constant is there with respect to C, let us imagine I have x value. If I differentiate with dy, what will it do? X coordinates, this is x, this is y, this is z. The x coordinates is independent of y. If I differentiate with respect to y, pakka it will give 0. It will give 0. If it is independent. Similarly, if it is independent, it will give 0. So what can I do? I can write plus v or minus v. By writing plus or minus v, it will, now I can do, now nothing would change, because if I differentiate with t minus v, again t will be differentiable, but v will constant with respect to q dot. So it will 0 again. So now I got the repeat that t minus v is equal to, I will replace with value L, and my value will be is equal to again d by dt and qk dot L minus now qk, and this will be L qk is equal to 0. This is our Lagrangian equation. Lagrange. Lagrangian equation. This is our final answer. Finally, we got our answer, and this was the term. So in this one, if you see, there is nothing like full or independent coordinate. So q dot means generalized coordinate. So all the equation we converted in generalized coordinates. Now we can solve the equation. So here with this one, our Euler Lagrangian equation parts get finished, and these are the main lengthest or bigger derivation. So it took a lot of time, and it's also somewhat difficult to understand also. So I think I made you clear about on this one. You got clear idea about this, and so if you like our video, really like our video, so and way of teaching, so please like our video, give your comment, give your opinion in comment. So it will motivate us to in future. So today's class we will finish here, and next part we will meet you in next video. Thank you. Bye.